So 6-2 is all about radicals and rational expressions. So if we flip the page, we have a couple of properties. So, and I'll go through them kind of as we go through an example. So it says real nth roots of an a. So let n be an integer greater than 1. So n will be that root, okay? And then a will be a real number. So an example of a real number can be a fraction, could be a negative number, could be 0, could be 7, could actually be negative square root of 16. So those are real numbers, right? And we have n square root of a. When n is the integer greater than 1, and so the n is the root of an a. So this is the root. Maybe that is easier to see. So this is the root of that a. So the first property is, if your n is odd, so if the n is an odd number, so 3, 7, right, and so forth, then a has one real nth root, only one number as a solution. So you can write it as square root of n equal a's, and those two are equivalent, equals a as 1 over n. And this will make more sense as you kind of see the numbers. So let's pause here, and this is just like an example a. So it says find the indicated real nth root or roots of a. So as we said, n is the root, oops, here it is, n is the root, and then a is that number that goes under square root. So negative 27, and that's our root. So if n is odd, then we only have one solution. So here is how you plug it in. If you have a calculator like this one, let me make sure it actually shows. I'm turning it on. So we have 3 square root of negative 27. So you have this one. You can click 3, and you may have it on your calculator. Then notice how I have that x square root in kind of yellowish green. So it's the second function. So I click my 3, then I went second, whoop, this one. See how that x actually come up? So what it means is that it's taking that 3 as the root, and then I plug in my negative 27. So negative, not minus, negative 27. And if I click enter, I will get the answer. It's negative 3. There's only one solution. If you're using graphing calculator, you're going to, let me clear this. So graphing calculators, I want to make sure you guys see all of it. Whoop. Because it's 3, so I'm going to click 3, just a 3 back here. Then you actually have to go and click math. See how there's the math button? If you click math, then you're going to scroll. See how number 5 has that x square root of 5? So you can scroll, and I am going to pick that 5, enter, whoops. So now I see this. And then we have that negative 27. So negative is this button, 27. You should be able to seeing something like this. And now you get to click enter. And you have the same answer. So it seems like it's a little quicker with the regular old-fashioned calculator, but they all give you the same answer. So the reason why we have negative 3, it says right here, when that n is odd, and obviously 3 is odd, then we have one solution. And look, this is why this is true. So this is happening because if you take negative 3 times negative 3 times negative 3, what will you get? Negative 27. So this is almost like a way for you to check, like, yep, I would get that back. It's almost like a check, but you don't have to do that. This is just for you to understand. So let's do B. So n is a root, square root 16. This is not an odd number, so this is obviously even. And here is the property for even. When your n is even and a is greater than 0, obviously 16 is greater than 0, then a has two real n roots, positive and negative. And I'll tell you why that's the case. So when n is even, you will have positive and negative answer. So plug it in, whichever calculator you want. So let me clear this. So I will click 4, then second, 16. What do you guys get? Plug it in and see what we're getting. 2? Awesome. So it's 2. But it says I should have positive and negative 2. Let me show you why there's 2 answers. So this is true because if you take 2 times 2 times 2 times 2, you will get 16, right? But if you take negative 2 times negative 2 times negative 2 and times negative 2, you will also get 16. You will also get 16. That's why we have 2 answers versus 1 answer. Now, in homework, when you guys are doing this, when they're telling you a is 16 and you plug under square root, you assume that this was the original problem. Like this was the original problem, you just like practicing putting a and b and a and n into it. I'll come back to that kind of comment that I just made in a second. All right, so let's keep on going. It says, if n is even and a equals 0, then a has one real n root, which is 0. So you have square root of 0, and that's an even number, that will be just 0. So if there was a square root of 0 over 4, you'll get a 0. The last property on this page is if n is even, so if your last square root is even, and a is less than 0, you will have no solution. So, and if a is less than 0, there will be no n roots. And I'll show you guys why that is the case too. Okay, so let's keep practicing those. We have all the rules. Let's see if we can find the indicated real nth root of our a. So see if you guys can set this up. So a goes under square root, right? And 3 is our root. So we have negative under square root, right? And I read somewhere like, wait, if a is less than 0, then there is no real roots. Is that the case? True, only if your n is even. This is odd. Because this is odd, we can actually simplify it. So if you simplify it, what are we going to get? Let's plug it in. Maybe I'll use this one so you guys can practice this way. So we have 3 math, scroll all the way to 5, enter, and we have negative 125. What do we get? Negative 5. Negative 5. And if you wanted to check, negative 5 times negative 5 times negative 5 will give you that negative 125. How about this one? So you're assuming that this was given to you, right? This is even, right? Even number. So when we have even number, we should have how many answers? 2, right? Because of this statement. So I know right away I will have 2, positive and negative. So if I take 6 square root of 64, or if you do it on this calculator, whoop, let me see if you can see that one. Okay, clear. So we have 6 math, whoop, sorry, 6 math, boom, was it 64? Yes, 64, ready, set, go, 2 calculators, boom, 12, 2, but remember, there's positive 2 and negative 2 that you could plug in and still get 64. All right, let's evaluate this one. So even negative under square root. If this is an even number, that will be no solution. But because it is an odd number, right, you can actually simplify it. So just plug it in. What do you guys get? -2. This one, very similar, right? So what you are taking under square root, right, is really square root of 3 to 8. That negative is in front of it, so you're not including it. So you're going to carry that negative. And then what's 3 square root of 8? 2. See the difference of notation? Now, example C, going back to what we talked in the properties. This is equivalent. N square root of A is the same thing as A 1 over N. They're equivalent. So if we have a fraction, you can rewrite it under square root and vice versa. So, if we have 16, so we know we're taking 16 to 1/4. So it's 16. Now here's a way to remember it. Notice how its numerator is 1. So it's 16 to the first. Notice how they're like almost next to each other. And square root. And that 4 is your root. Denominator goes into like the root part. Now, so you may say like, okay, we have a number. I'm raising it to an even number. And I just told you should have how many answers? 2, right? Here's the most confusing part. When they tell you that under square root is 64, right? Because we're just plugging it in. They just told us. You have 2 answers. But what they're saying is like, hey, you're taking 16 to 1/4. You know that it was originally 16, so you only have 1 answer. It wasn't -16 and +16. It was just 16 to 1/4. You're just rewriting it as and simplifying it. So therefore, if you simplify it, you will get what? 2. You will get 2. Can you see the difference? If not, it's okay. See how there's only 1 answer? 1 answer. They're telling you, hey, under square root you have A and it's 6. You don't know if this was positive or negative 2 or -2. Here you know because you're taking only 16 to 1/4. So this was positive, therefore you'll have only positive answer. The more you practice, you will kind of notice the difference, but that's the rule. All right, last but not least, in this page at least. So here we have square root, right? You're taking negative because it's parenthesis. -16. What goes in the numerator is the numerator is the number that is going to go to the power of 1. And then that 4 goes as your root. What do we get here? Is it -2? This is a tricky one. You haven't seen one like that yet. It's right here. So it says, if n is even and a is less than 0, you will have no solution. N is even. N is even. See how this was odd? We could solve the odd. But if it's even, there will be no solution. No solution. Because there's no way you could have taken -2 times -2 times -2 times -2 and get -16. Therefore, this is no solution. Only and only if this is an even. If it's an odd, we can actually solve it. All right. How's it going, you guys? Woo! So much fun. All right, 2 more, and then we're good to go. Those are actually very similar to what we have just done. So, rational exponents. Let 1 over n be the nth root of an a, and let n be the positive integer. So, I'm actually going to skip this part because I think it's confusing. But what it says, if you have a raised to the power of mn, you're going to assign the m to be the exponent and n be the root, which is really just what we have done back here. Those are really the same thing. So let's see how this works. I'm going to write, you have to evaluate this one. That's equivalent to the square root expression when 16 will go under square root. 16 will be cubed, and the root is 4. Remember, whatever's next to it kind of goes next to it under square root. Whoop. And then 4 is our root. So whatever's in the denominator is the root. There's two ways of doing this problem, whichever way you prefer. So the order does not matter. And I will show you, and you pick whichever way you prefer. So what we can do is we can say, because we have two things. We're taking the root to the fourth, and then you're also taking 16 to the power of 3. Doesn't matter. So for instance, let's say if you keep the square root of 4 and plug in 16, whoop, let me turn this on. So if I have 16 raised to the power, the little hat, of 3, you end up with 4,096. Now you have to take and say 4 second 4096. You end up with 8. So that's one way of doing it. Or you can actually do the other way. So you can say, okay, if I take 4 of 16, I'll end up with 2. 2 to the power of 3. And 2 raised to the power of 3 is 8. So the order of either taking 16 to 3 or square root with the root of 4 to 16, you'll get the same answer. So whichever you prefer. So 27 goes under square root. Remember, 4 is right next to it, right? So it's 27 to the power of 4, and then you take the cube root. Cube is actually the 3. Whichever way you prefer. I kind of like taking the root first because I'm working with smaller numbers, but it doesn't matter. So I will take clear. So I will have 3 square root of 27. I end up with 3 to the power of 4. So 3 to the power of 4. We end up with 81. Notice how there's only one answer, not positive and negative, because you know you're taking 27 to 4 over 3. You know exactly what it is. All right, how about this one? So here we have, okay, so we have an odd number, negative, so I know I can actually simplify it. So we have, let me clear this, 3 cube root of negative 125. Negative 5. Did we have that earlier? Just gonna say negative 5. That's funny. And here it is. Under square root. We have, now notice how they have parentheses because they're saying we're taking everything. If you saw this, you would have negative, and then you would go square root of 64 squared over 3. You need to see the difference of the negative. So it's negative 64 squared, extend it, and this will be cubed. So if you take cube of negative 63 is negative 4, you will square it, and we are getting 16. And last on this page, 9 raised to 5 over 2. So 9, and then to the power of 5, and this is squared. One thing I haven't mentioned to you guys yet is if you have a number, whatever it is, so let's say 16, and they don't tell you what the root is, you assume it's 2. If they don't say what it is, you assume it's just square root, and that's 2. It's just kind of like saying, like, hey, number is always the power of 1. This always is 2, unless they specify exactly what it is. So if we simplify this one, square root of 9 is 3. 3 to the power of 5 is, plug it in, 2, 4, 3. 243. All right. How's it going so far? Not that bad? Awesome. All right, last problem of the day. Yay! Rectangular story problem. So it says a radius of a sphere. So sphere, here's a ball, right? A sphere. A radius that goes from the center to one of the points of it. So that's my radius of a sphere is given by the equation r equals, in parentheses, 3 times v divided by 4 pi, and the whole thing is being raised to 1/3, where v is the volume of the sphere. Find the radius of the beach ball to the nearest foot. Make sure you use 3.14 as a pi, and then they also give us the volume of that sphere. So I'm going to copy this first before I plug in all the things that we know. So 1/3. Now, when you see a fraction, you should be able to kind of connect, oh, this has to do something with square roots, because you can rewrite the fraction of an exponent as a square root. So let's plug it in what we know. We know what the volume is. So it's 3 times. Volume is 113. 4 times, and they want us to use 3.4, I'm sorry, as a pi, 1/3. We're not going to distribute the 1/3 because we have no variable here. We can just simply keep on reducing and simplifying things. So 3 times 113 is actually 339. And 4 times 3.14 is 26.99. Let me actually double check. 4 times 3.14. 4 times 3.14 is actually 12. Wait. Yeah, I copied the answer wrong. It's actually 12.56. Sorry, my bad. So what we will do next is we are going to simplify. It's just a fraction. It's 339 divided by 12.56. So let's plug it in. 339 divided by 12.56. You end up with 26.99 to 1/3. Now this should look familiar to you guys because now we can actually rewrite it. This is the same thing as 26.99, right, to the first power, because yes, that is that one there, and then this is your root 3. And now we can just plug it in and see what that really is. 26.99. We end up with about 2.999, which is approximately 3 feet. That's our radius. So it's about 3 feet. Okay, that is it for today.